First one is find the exact value of this expression. So 5 pi over 12, we should probably figure out what degree angle that would be. So if I multiply that by 180 over pi, let's see, what am I going to get?
75.
75. So sine, this is really sine of 75 degrees, which for us, we can break that up into sine of what two angles that we're good at?
45 and 30.
Okay, added together. Okay, so I have the sine of a sum of two angles. So that means that we go sine of 45 cosine of 30 plus cosine of 45 sine of 30.
Why did you do sine of 45? What if I did 30 plus 45? Doesn't matter.
It'll be the same. You'll get the same thing as me.
But because I didn't get, like, my things, like the denominator wasn't the same on mine.
Okay, let's see what happens. Because we should get the same because you're just going to have this one over here and this one over there. But you're adding, so adding and multiplication are both commutative, so it doesn't matter what order those things happen. So for this one, it won't matter. All right, so sine of 45, so I make my little 45 degree angle. So I got 1 square root of 2. Sine is, yep, because it's opposite over hypotenuse, so I'd have 1 over the square root of 2. But when I fix it, I'm going to get the square root of 2 over 2. Did you get that?
I did not anywhere. What was that? Sine of 45.
Right, so it was 1 over the square root of 2. But I had to rationalize it, so I multiplied by the square root of 2 over the square root of 2. So I get square root of 2 over 2 for the first one.
Oh, yes, I did get that. I didn't rationalize it.
Okay. And then when I have cosine of 30, so that's here, 1, 2, square root of 3. Cosine is adjacent over hypotenuse, so that's square root of 3 over 2. That's already good.
Yeah, that's what I got. Okay, I remember that.
Plus, now this one, I have cosine of 45 degrees. Yep, because it's still 1 square root of 2, adjacent over square root of 2. Again, I get 1 over square root of 2. When I fix it, square root of 2 over 2. And then here I get sine of 30 degrees. That's 1, 2, square root of 3 still. But sine is opposite over hypotenuse, so that's 1/2. So when I multiply the first set of fractions together, square root of 2 times square root of 3 is square root of 6. Over 2 times 2 is 4. Plus square root of 2 times 1 is square root of 2. Over 2 times 2 is 4. So they have the same denominator. So I get square root of 6 plus square root of 2 over 4. You can't put a square root of 6 together with a square root of 2 because they're not the same type.
Are we allowed to put the triangles down on that paper?
No. You gotta know those.
I know what.
I don't ask you guys to memorize much, but that one I want you to.
How about the graphs? Like, are we allowed to put the graphs of the sine, cosine, tangent?
No.
Okay.
General shape. You just have to know. Because all the graphs are the same. They're all pi over 2, pi, 3 pi over 2, and 2 pi. So you just have to remember the shape.
Oh, a huge question here, Shannon. I don't know if you can answer this real quick or not.
This is 17. 17 was just, I didn't know which ones to use.
Okay. Well, cosine of 165, what can I break that up into? Now, it's not going to be in just 30s and 45s and 90s because we don't have anything that can get us that big.
I did
But
180 minus.
so you went 180 minus 15. The 180 we know, but the 15 we don't know.
Yeah, and like that's what I.
What did you try? 120 plus 45? That'll work.
What about 135 plus 30?
Wait, so you're allowed to use bigger than?
That'll work too.
Wait,
I mean, as long as we...
Hang
I
on.
thought you had to use 45, 90s.
Technically we are, because watch what happens when I draw. Let's write this one out, and then I'll show you where the picture is. Okay? Because it all has to do with those reference angles. 120 is 60 away from the 180, so this is actually a 60-degree angle.
Oh,
Okay? The only thing that's going to change is their signs. because it's now in the second
What
quadrant.
if I did
Ah.
135?
Well, that's all I need.
That'll work too.
Technically.
But I know that because I just told Matt that it works. All right, so cosine, let's see. So for cosine of two things being added together, we get cosine of 120, cosine of 45, minus sine of 120, sine of 45. Okay, so if I draw these little pictures, cosine of 120, now that's going to be 30 past my 90, which I'm going to get this triangle, 1, 2, square root of 3, but the 1 is negative. Okay, so this one, cosine is adjacent over hypotenuse, so this will be negative 1/2. Okay, so even though it was a number that wasn't a 30 or 45 or a 90 or a 60, it actually was one of those because of the reference angle.
Okay.
I think you should get negative 2 over 2.
I got
For the cosine at 135.
radical 2 minus radical 6 of them.
All right, cosine is adjacent over hypotenuse, so I'm going to get square root of 2 over 2 again once I rationalize it. All right, and that's minus sine of 120. Sine is opposite over hypotenuse, so that's square root of 3 over 2. And sine of 45, 1 square root of 2. Again, I'm going to get a square root of 2 over 2. All right, so when I multiply these two together, I'm going to get negative 1 times square root of 2 is negative square root of 2 over 4 minus square root of 6 over 4. They have the same denominator, so I get a negative square root of 2 minus square root of 6 all over 4.
Then just left it. That'd be wrong.
Left it this way.
Yeah.
It's not simplified, but yeah.
I just 45 minus 30.
If it's
That's
like
right.
that, if it's 45 minus 30, okay.
45 is first, so exactly.
If I'd said 30 minus 45, how would I know if that's wrong?
Well, you don't get 15, you get negative 15, so it's wrong.
All right.
30 minus 45. Subtraction is not commutative, so order does matter.
Gotcha.
So that means that it matters what order you put it in. Now what you did have an option of is it didn't matter whether you went tangent of 45 minus 30 or if you went tangent of 60 minus 45, those are the same. And the math will all come out to be the same.
All right. I got, can we do 45 minus 30?
Uh-huh. So tangent of 15 is really 45 degrees minus 30 degrees. All right, so I have to go through the subtraction of two angles within a tangent formula. So for us, that's going to be tangent of 45 minus tangent of 30 over 1 plus tangent of 45 tangent of 30. All right, well, tangent of 45, opposite over adjacent, that's 1. Tangent of 30, oops,
What am I saying?
is opposite over adjacent, so that's 1 over square root of 3. That's square root of 3 over 3. Over 1 plus tangent of 45 is 1 times tangent of 30 we just found to be square root of 3 over 3. All right, so I have fractions within fractions here, so I'm going to have to get common denominators. So instead of a 1, I'm going to have a 3 over 3 minus square root of 3 over 3. Over, same thing down here, I'm going to get 3 over 3 plus square root of 3 over 3.
You can't do anything with that, right? I was like trying to figure out if you could do anything with them.
Yeah, I can put them together. They both have the same denominator, so I have 3 minus square root of 3 over 3 over 3 plus square root of 3 over 3. Multiply by the reciprocal.
Oh, yeah, I did that. But then, like, you just get 3 minus radical 3 over 3 plus radical 3.
So these cancel. So I get 3 minus square root of 3 over 3 plus square root of 3.
That's fine, actually.
Well, it's not rational because I have a square root of 3 in my denominator. So how do you fix this one? I'd have to multiply it by... That won't fix it either. What is it? Yep. What do I multiply it by? close, the conjugate. So 3 minus square root of 3. So I have to FOIL. 3 times 3 is 9. 3 times negative square root of 3 is going to get me negative ugly. And square root of 3 times 3 is positive ugly, so they cancel. And then I get 3 times negative square root of 3 times square root of 3. So I'm going to get negative square root of 9, which is 3. So I get that. And then in the top, that one gets pretty ugly. So 3 times 3 is 9. Negative 3 square root of 3. Negative 3 square root of 3. Plus square root of 3 times square root of 3 is square root of 9, which is 3. So when I simplify it all, 3 plus 9 is 12, minus 6 square root of 3, all over 6. What do all three of those things have in common? Bigger, 6. So I'm going to get 2 minus square root of 3. The worst part of that one was the simplifying. Conjugate. Why did I use the conjugate? Because I wanted that middle part to cancel out so that I just got a whole number down here in my denominator. You can't leave a square root in the denominator. It's not considered simplified. So I used the conjugate, and that ended up getting rid of all the roots. Now I ended up getting pretty nasty roots up in the top, but when it was all said and done, it actually came out pretty clean, considering. Okay, this one doesn't surprise me that you guys asked for it, because there is no secant formula on here.
Let's just do 1 over 13.
Yes, you can. So we already know what pi over 12 is. You guys have seen it enough now. What is it?
15.
Yeah, and so since this one was negative, it's going to be negative 15. Okay, so what we really want is the secant of 30 minus 45. Or you could use 30 or 45 minus 60. Anything that will get you negative 15, you're good. Okay, but we don't have a formula for secant, so we're going to go 1 over cosine of 30 minus 45. So we need to just keep putting a 1 over whatever it is that we find for this one. So cosine of two things being subtracted, this is going to be 1 over cosine of 30 cosine of 45 plus sine of 30 sine of 45.
Could you just do regularly, and then just do 1 divided by with the full answer and you're done, or not?
You could do it regularly without being under a 1, and then take your answer and just flip it.
Okay.
Because secant is the reciprocal of cosine.
Alright.
Which is what we're going to end up having to do anyways here, because I'm going to have 1 divided by a fraction, and then we'll have to.
Alright, that just seems.
But my guess is that there's going to be some kind of ugly conjugate fix at the end of this thing again.
Alright.
Okay? So we'll have to see what happens. But the rest of this is pretty straightforward. So cosine of 30 is 1, 2 square root of 3. So cosine is adjacent over hypotenuse, so this is square root of 3 over 2. Cosine of 45 degrees plus sine of 30. That's back. Actually, I don't really need a new graph because I have this one over here. Sine is half. And then sine of 45, also square root of 2 over 2. All right, so I'm going to get square root of 6 over 4 plus square root of 2 over 4. That's square root of 6 plus square root of 2 all over 4. And that's all under 1. So when I multiply by the reciprocal, I'm going to get 1 times a 4 over square root of 6 plus square root of 2, which is 4 over square root of 6 plus square root of 2, which is not simplified.
Of course not.
I've got all these radicals in the denominator, so I need to fix it by multiplying by
Conjugate.
conjugate. So square root of 6 minus square root of 2. So in the top, that's actually not too bad because I just distribute. So I'm going to get 4 square root of 6 minus 4 square root of 2. In the bottom, when I FOIL this, square root of 6 times square root of 6. 6. Square root of 6 times negative square root of... So it's going to be negative square root of 12, but then I'm going to get a positive square root of 12, so they cancel. So then square root of 2 times negative square root of 2, negative square root of 4. 2. So I end up getting 4 square root of 6 minus 4 square root of 2 over 4. All of those have a 4, so I just get square root of 6 minus square root of 2. No, it's just that simplifying part. Remember, you can't leave a square root in the denominator, so you have to keep rationalizing it. That's kind of a hassle, but not something you haven't done before. All right, I think that's all of that type.